the digital circuits and systems. I hope that everyone have joined the class.
Most of us, sir.
Okay. Okay, I hope that the screen is visible.
Yes, sir.
Okay, good afternoon once again. Is the screen visible now?
Sir, and your voice is a little low, sir.
Yeah, I can improve that. Okay. Okay, shall we start the class? Hello.
Yes, sir.
Okay, okay. So we will just start with discussing the basics of number system. Hello.
Yes, sir.
Okay. So basically, the number systems, we have the normal number system, which is the decimal number system.
Sir, your voice is low, sir.
Is it audible now?
Yeah, now it's good, sir.
Yes, sir.
Okay, I think the mic is not trouble. Okay, I will rectify within next class. So we have basically four number system: decimal number system, binary number system, hexadecimal number system, and the octal number system. Okay, so we all are very much familiar with the decimal number system, but we will be new to the binary and other number systems. But it is very similar to the decimal. But in what happens is that in the decimal number system we have 10 numbers, that is from 0 to 9. Whereas in binary, just as the name suggests, it's just two numbers, 0 and 1. And when it comes to hexadecimal, we have 0 to 16, and it is like still single digit 0, 1, 2, 3, etc. till to 9, and then after that the alphabets will come A, B, C, D, E, F. Okay, and in the octal we have just 8 digits to represent the whole numbers. So first what I will do is that I will explain the decimal number system that we all are familiar with in detail, so that we will be able to grasp the other number systems. Hello, am I audible?
Yes, sir, you are audible.
Yes, sir.
Okay, so I straight away jump to the class. I hope all are fine with that.
Yes, sir, it's fine.
So this is the decimal number system where we have, just as I said, the 10 different symbols or digits are there. That is from 0 to 9. Okay. All the number system in the system represented in terms of the 10 digit only. Any number that we will, like it will be 1 lakh, 1 crore, whatever will be the number, we will be using these 9 numbers to represent that. Okay. So, and that's why it's decimal, and decimal means 10. This for example, we will tell decade. So what the decade means? It's 10 years. So this decimal number system have a base of 10, and hence it is called decimal. Then we will discuss about the weights, how this decimal number system is coming, and we will consider an example here. For example, 5396.8541. Okay, so we have a point, that is a decimal point is there, and towards the left and right the weights are there. So if we consider that one side will be the most significant bit and the other side will be the least significant bit. So if we consider in this number with the 5396.8541, 5 is the most significant bit and the 1 is the least significant bit. Hope you are getting an idea about this. Okay. So how we come to know that how this 5396 is calculated is shown just below that. For example, if we how to calculate this number, for each position there is a weight as shown in this figure, not in this here. So for example, the weight of 6, which is the digit which is just below the decimal, just before the decimal, is 10 raised to 0, that is 1, and the other one is 10 raised to 1, which is weight is 10, and for 3 it is 10 square, that is 100, and for 5 it is 10 raised to 3, that is 5, it is called 5000. So likewise, we can calculate using the weight system. This 5396 is calculated as shown here. 5 into 10 raised to 3 plus 3 into 10 raised to 2 plus 9 into 10 raised to 1 plus 6 into 10 raised to 0. That's how we will get 5396. And the fraction part is can be expressed as 8 into 10 raised to minus 1. So if we go to the other side, the first number will be 10 raised to 0, and when it is in the other part of the decimal, it will be 10 raised to minus 1, 10 raised to minus 2, 10 raised to minus 3, and 10 raised to minus 4, and so on. So in this case, we will calculate this as 8 into 10 raised to minus 1 plus 5 into 10 raised to minus 2 plus 4 into 10 raised to minus 3 plus 1 into 10 raised to minus 4. That is 0.8541. So in total, we will get 5396.8541. So that I hope that you are clear with the decimal part, because it is very important so that I can explain the other number systems. Hello.
Yes, sir, it's clear.
Why I'm asking is that if I'm getting disconnected also, I may not come to know since I'm using this window. Okay.
Okay,
Yeah,
sir.
okay.
Okay. So you are clear with the decimal number system. In similar way, I will explain the binary number system. So in decimal, I told like the 10 is the base of the system, but whereas it comes to binary number system, 2 is the base. Okay. So just like we calculated the decimal value of the decimal, how we calculated the 5300 and something, we can calculate any binary number value by using the same system. Instead of 10, here we use 2. And towards the left side, it will be positive numbers 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and so on. And whereas to the negative side, it will be, sorry, as the decimal side, it will be 2 raised to -1, 2 raised to -2, 2 raised to -3. Okay. So for example, the binary weights in the binary number 11011.1011. If we calculate, we can calculate a similar way. We can calculate in the similar way. Hello.
Yes, sir.
Yes. For the weight of 1, we will give 2 raised to 0. Then can somebody calculate and tell the number decimal, convert to decimal?
Yes, sir. Before decimal point, it's 13, sir.
Decimal? It's 13, okay. That's fine. The other part we can calculate later. Okay. Then I am going to the other number system. That is the hexadecimal number system. So in hexa number, we are having the similar to the decimal. First 0 to 9 digits, we are using the normal number system. And in an hexa number system, we have 16 digits are required. Okay, it has a base of 16. So we need 16. Just as in I said in decimal, we need 0 to 9. In binary, we need just 0 and 1. In hexadecimal, we need 16 numbers. So it is called 0, 1, 2 to 9, and then A, B, C, D, E, and F is used. Okay. So to represent any in the similar way to decimal and binary is calculated, we can use the same weight. Like here, the weight will be 16. So any point we are having any number, we have to multiply it into 16 raised to 0, 1, and so on. Okay. We'll all work out all many examples of the same, and we'll be clarify the same things. Now I will go back to the octal. Octal, very similar to the binary, decimal, and hexadecimal. It's very similar, and the weight calculation is similar only. But here the numbers used will be from 0 to 7 only. The maximum value of any digit it will be represented will be 7. When it comes to hexa, it will be F. When it comes to decimal, it will be 9. And when it comes to binary, it will be 1. I hope you are clear with that. Hello.
Yes, sir.
Okay. Now hope you are clear with the 4 number system and like how these numbers will come. Like for example, in binary, only 0 and 1 will be there. When it comes to octal number, any number with from 0 to 7 only will be there. In the octal number system, 8 won't be there. So if you see a number like 823, you can assume that you can understand that that is not an octal number. It could be anything more upper than octal. So for it could be an hexadecimal number or it could be a decimal. Okay. So to conclude, I will just tell that what are the 4 numbers and what is the base. For decimal, it is the base is 10, and the symbols 0 to 9 are used. And for binary, the base is 2. The symbols 0 and 1 alone are used. For an octal, the base is 8, and the symbols 0 to 7 alone is used. And when it comes to hexadecimal, base is 16, symbols 0, 1, etc. to 9, then A, B, C, D, and F are used. So just for the fun part, I have kept like when it comes to computer, we only use the binary numbers, and the other number systems are used by okay. Now, so like why we are learning this number system? Can we convert from one number to other and all these things? So if you are having in any number system, we can convert to each other. Like for example, from decimal, we can convert to octal, we can convert to hexadecimal and binary. And in the similar fashion, from this 4 number, we can convert to any other. For example, if it's a hexa, we can convert it to decimal, binary, and octal, and so on. So For example, we'll convert okay, we'll do some small exercise. Hello, I'm audible.
Yes, sir.
Convert 16.73 into binary number. 16.73 into binary. Did you get the answer? How much is it? How much is it? No, how much is it? The answer. What double zero? What? So how can convert this? Okay, that's fine. So that's the answer. So I hope everyone is clear about converting 16.73 into its equivalent binary number. Okay. So another example is to convert 65.35 to hexadecimal. Please do this. Meantime, I will take the attendance as well. Roll number 1.
Present, sir.
2. 2 is absent. 3. 4.
Present, sir.
5. 6.
Present, sir.
6 is present. Okay. 7,
Present, sir.
8, 8, 9, 9, 10, 11,
Present, sir.
12, 13,
Present, sir.
14, 14, 15, 16,
16 present, sir.
17,
Sir, 15 present, sir. My network was slow, sir.
14
17.
present, sir.
17 also present, sir.
14 Kalidas Benny,
Sir, present, sir. I'm 15, sir.
Sir, Kalidas Benny 15, sir. Jubin Thomas 14, sir. Both present, sir.
18,
Present, sir.
19,
Present, sir.
20.
Present, sir.
So did you get the answer? 20, roll number 20, did you get the answer?
Which one, sir?
I had asked a question in this.
16.73 doings.
That was converted some 10 minutes back. After that, we did another one. At least you can tell me the question.
16.73
That was last time.
converting to
That was converted
binary.
last time. That I have kept it in the screen also. The next question was asked after this.
65.35 convert to hexadecimal.
Did you get the answer?
Doing, sir.
Okay.
This.
21,
Present, sir. Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
29, 30,
Present, sir.
32,
Present, sir.
33, 34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41, 43, 44,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48, 48, 49, Sheikh Fardeen Ahmad Pasha. Absent.
Absent, sir. Sir, but 43 is present, sir.
Okay. Siddharth.
Present, sir.
Srinidhi.
Present, sir.
52.
Present, sir.
53.
Present, sir.
54.
Present, sir.
55.
Present, sir.
56.
Present, sir.
57. 57. 58.
Present, sir.
59.
Present, sir.
60. 60.
Present, sir.
61.
Present, sir.
62.
Present, sir.
63.
Present, sir.
64. 64. 64.
Sir, 64 is present, sir.
34. Your roll number 34, right?
Yes, sir. 64 typed in the chat box, sir.
So how many of you got the answer correctly? Hello.
Sir, I have doubt in the decimal to binary conversion.
You ask me. Decimal to this previous
My
one.
yes, the previous one.
Okay. Okay. Ask.
Yes, sir. Here in the decimal part after point, we stopped with 0.36 now, sir. Why didn't we continue by multiplying it with 2? We get 0.72 carry 0 and again multiply with 2 carry 1. Why did we stop here, sir?
No, that will it will not end. So we will stop by 1 point.
Sir, do we have any particular reason why where to stop, or else we can stop wherever we want?
No, like normally sometimes it will repeat 10111 1011 like that. We will get a repetition.
Yes, yes.
Okay. So in this case, we have stopped with the 5 digits. Okay, shall we move to next question? This is clear for everyone. Like it is the simplest one for converting from a binary, sorry, decimal to binary. Okay, then I hope everyone have done this one as well. Convert the decimal number 65.35 to hexadecimal. Hello. Am I audible? Hello.
Yes, sir, you are audible.
Yes. Is this one clear? How can we convert
Yes,
the
yes,
65.35 hexadecimal from decimal?
yes, sir, it's clear.
Sir,
Shall
I
I
have
move?
a doubt, sir.
Yeah, you
It's a
can.
different doubt.
Yeah.
If hexadecimal and octal number systems are not used by humans in computers, then why are we learning it, sir?
Who told it's not used anywhere? Like
Sir,
there
in that
will.
table it said it's not used
It's
by
not
both
commonly.
humans.
It's that's why I didn't discuss that too much. It's not commonly used by humans. We normally
Oh,
use decimal number system. Okay. Then we use binary number system is used by the computers. Okay. And why we use binary in this processor? Because it is very complex for the decimal computation part. Okay. So I hope you all know how our processor is working, what's inside a processor. We will be having, I think, around 2 billion of transistors. I hope you are aware about transistor.
yes, sir.
Yes. So the transistor, what it will do is if we accordingly, it can switch, and in the output, it can give 0 and 1. So many transistors will be like there will be like so as I told, it will be billions of transistors connected together to do a process. You are aware about Moore's law? I hope I have answered more than what you asked. Any other
Yes, sir.
queries?
Thank you, sir.
No, this actually digital is a very one of the basic subjects, and it is a very important subject for everything. If you are going to any stream, including programming or whichever is, it is not just based for electronics. It is based for everything. Like if you learn C programming, you need a digital, and for everything you will be like now we then I think many of these parts will be covered in +2 for you or in school days. Now then we will be learning more about Boolean algebra, gates, and all those basics will be covered in the module 1. Okay. So for a start, we will deal with the number systems. Okay. So everyone is clear how we got 65.35 in decimal to 41.59 in hexadecimal. Yes, can anyone convert this to octadecimal and give me the answer? Anyone? Okay, at least give me the octa of 65, which will be relatively easy.
One zero one, sir.
Okay, that is correct. Then binary of 65. Anyone?
One zero 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 one, sir.
Can you tell me once more?
1
0 0.
0 0 0 0 0 1.
So it will be 5 zeros and ones apart, right?
Yes, sir. 5 zeros.
Okay, that's correct. Hope you are not using a calculator because that won't help our case. So convert the decimal 570 into octa number. (570) to octa number.
Sir, 1072.
10.
1072.
Can you convert this into hex number? Someone else, please. Hexa number.
Sir, 23.
Okay, how did you do that? 64, how did you do that? Hello? The answer is correct. I am asking, how did you do that? What was the steps involved?
Sir, like we divide 570 by 16.
Okay. Then what we will get? No, it's an open discussion. Everyone will be able to.
Yes, sir. We'll get a remainder 35, which again we have to divide by 16. Then we'll get 2. Then again 2 by 16, we'll get 0, sir.
Okay, next question. Okay, now we will do the opposite way. We will convert binary number to decimal. This is an example. Okay, should I explain this procedure? How to convert binary to decimal? If any doubt is there, please ask it in the. Rather than discussing in the class, can you just ask it here? I can explain it here. Yes, A is 10. Somebody is discussing it in the chat box. Sanjay Reddy, you can ask the doubt. I can explain it.
So, sir, I got my doubt clarified.
Okay. No, it will be very boring to speak from one end and I don't know what's happening in the other end. So somebody asks a doubt, it will be time pass for me as well. Okay, so you are clear, like we did some exercise. So like we got a basics. Now I think you have got an overall idea about like converting numbers. At least if you don't want to directly convert from one to another, you will be able to manage it like by converting to binary. Or like you can bring it what reverse engineer at least, I hope. Okay, but we will be studying all methods like from binary to decimal, decimal to hexa. Individually, we will be studying everyone. So the next one is this is binary to decimal, which is easiest of all. Now, how to convert from binary to octa? Okay, so what we do is that we will split this thing into 3 because 8, you know, right? 8, 2 raised to 3 digits. Like for every octa number can be represented into binary, means if you represent from 0 to 7, 7 means it will be 1, 1, 1. So to convert a binary number back to octa, what we do is that we will group them into 3 numbers. Like if we have 9 numbers, we will group from least bit. Least bit we will group as 3, 3, 3. If we have 10, we will group as 3, 3, 3, and then 1, and we can put the 2 zeros in the other side. Okay, so in case of this one, 1, 1100001, which is having a base of 2, which is a binary number, we need to convert that into octa number. So it is very comfortable since it has 6 digits. We convert the least significant bits, that is 0, 0, that is 1, 0, 0, and then the other group which is 0, 1, 1. Okay, so I'm reading it from the opposite end, that is because of the least significant side, that is 1, 0, 0, which is equal to 1 in octa number. And then again, if we consider 0, 1, 1 or 1, 1, 0 is equal to 6. So like that, we will get 1, 1, 0, 0, 0, 1 in binary is equal to 61 in octa number. Okay, are you clear on this? I hope it's clear. Okay, I will give an example. Let's say let's say 7-digit number, like it will be 5 ones and 2 zeros. Can you convert that into octa? 5 ones and 2 zeros, total 7-digit number.
$174, sir.
Yes. Octa it is 174, right? Correct. Can
Yes,
you
sir.
convert the same to decimal?
Yes, sir.
It will be difficult to convert directly. We have to use the weight method. We don't have a shortcut like this to decimal, or we doesn't know it as of now.
Sir, 124 in decimal, sir.
That is correct. Okay, can someone else tell me the hexa number of same one? Roll number 20. Roll number 20.
Sir.
Yeah, can we tell me the hexa number for this one? 5 ones and 2 zeros.
5-1.
Hexa number.
Sir. Yes, sir. 1 minute.
Okay, meantime, let's consider another binary number. That is 001 000 101. This is binary. Convert to octal. Same method we can follow. We can group them into 3. Since it is having 9 digits, we will get 101 000 and 001, and which each one can be converted into octal numbers. That will be 1, 0, and 5, and we will get the number 105.
Sir, your voice is too low, sir.
Sorry, I just okay. So I'm telling that we can convert the binary number which is having 9 digits, that is 001 000 101. We can group them into 3 groups. First group is 001, second group is 000, and the third group is 101. And the octal number for each one is 1, 0, and 5. Thus, we are getting the answer 105. Okay. I
Yes,
hope
sir.
that everyone is clear on at least this one.
Sir, we should start grouping from right side, right?
Yeah, you have to group it from right side only.
Okay, sir.
You have to, yeah, okay. For example, I don't think I have an example with this 10 digits. For example, if we are having 10 digits, okay, then we have to group from the right side. The first 3 digits will be grouped 3 3 3. Then 9 digits will be gone, and the last number will be grouped. For example, if we are having 1 followed with 9 zeros, okay, then the octa number will be 1 0 0 0, 4 digits. Understood? Are you able to follow?
Yes, sir.
Okay, so what example was that? If 1 followed by 9 zeros, then it will be, in the octa number will be 1 followed with 3 zeros. Understood? Huh? If you have any
Yes, sir.
doubt, please ask. Now we will convert binary to hexa. Just like we converted from binary to octa number, we will convert binary to hexa. Okay, the only difference here is that here we will group it as 4 digits. Instead of 3, here we are grouping as 4 digit, and the hexa number is substituted for each 4 digit. Okay. Can everyone try this number, how to convert this one?
Sir.
Yes.
Sir, here they grouped it from left side, sir. After the decimal point.
You have to group it from the decimal point. We have to group it like you consider as center. No need to consider as left and right. Okay. From the center, you will group to both ends.
Oh, okay, sir.
Okay. I'm not telling that for a decimal. When we later before this we were discussing about normal numbers. It was not a decimal number. Okay. From the decimal point, you have to left and right. You have to group. You can see that in this example, 3 zeros are added in the MSP side and 2 zeros are added in the LSP side.
Yes, sir.
Okay, and then the corresponding hexadecimal number is just substituted. For example, 1100 is C. 1011 is B, 0111 is 7, 1011 is B, and 0001 is 1. Okay, so you can add as many zeros in both ends, but here the answer won't change because zeros will be always 0 in both ends, which will be in MSB and 0 and LSB zeros. Nothing will change, right? In case of decimal numbers. Okay. Now, how can we convert a octa number back to the decimal number? So we have like all the iterations of the conversions I have explained with the example. So this is very easy. You can use the weight method. That is 1051 with the weight is base is 8. Okay, so you just multiply it with the base 1051 and we will get the decimal number. It is 553. Okay, can I give one more example? So you consider an example of 1051.51 with the base 8. So what will be its decimal? 1051. Okay, I will stop shortly. Please, sorry for I didn't notice that the time is up. Only one more conversion is left. I hope this octal to decimal conversion is clear. Any doubts for anyone? Okay, now I will go to the octal to binary conversion. This can be similarly done where we converted the decimal to, the binary to octal. We grouped 3 digits into 1 and with the corresponding octal value was given. Here just the opposite way. For example, in case of 70 with the base 8, for 0 we are substituting 3 zeros and for 7 we are substituting 3 ones. Okay, and the final answer for a 70 with base 8 is 111 with base 2. Okay. So with this, I am stopping today's class. Anybody is having any doubt, please ask. These are the textbooks which you can use for studying the subject. Anyone, any doubt? Please ask.
Sir, will we get notes, sir?
Yeah, notes will be provided later. You can note down all these things anyway. That's
Okay, sir.
on the slides itself, you can note down. Any other doubt about the class that we took today? Any conversion, any doubts from octal to binary, binary to hexa? I will share the slide with Shubham Shalva. I share the slide. Okay, then we will stop with this here today. If anyone is having any doubt, please ask. Okay, thank you.